So we continue. We are going to have a look at the peer-to-peer memory access. We know that from the marketplace, we have the servers that can host multiple GPUs. Okay, I went to the website of Supermicro. I put some system architecture of the servers that can host GPUs. So let's have a look at this one. It's a dual socket system, and then you have PCIe switches, and each PCIe switch is connected to 2 GPUs. So at the end, you can have 8 GPUs for this particular server. And this one, each PCIe switch could be connected to 5 GPUs. And finally, you are going to have 10 GPUs for this server. And the last one is that the second PCIe switch is connected to the first one and connected to 1 CPU, and each switch is connected to 4 GPUs, and the second PCIe switch is connected to a network adapter, and you can connect to the network. Okay, so these are the different quantity of GPUs and a different ways of connecting these GPUs to the server. But there is one point is that the GPUs, if the GPUs have to communicate each other by going through the PCIe switch and the PCIe link, there is a requirement that these PCIe switches and these GPUs have to be connected to a single root complex. So let's have a look at this one. You have a root complex with the first CPU. You have another root complex with the second CPU. That means these 4 GPUs can potentially communicate each other by going through the PCIe switch and the PCIe link. And these 4 can do the same thing. But one GPU from left-hand side, it cannot communicate with a GPU from the right-hand side. This is not okay. So the fact is that for 2 PCIe equipment to communicate each other, they have to belong to a single root complex. And this one is a little bit better because here you have only one root complex. And you have 2 switches connected to the same root complex. And that means these 8 GPUs, these 10 GPUs can communicate each other. And this is the same story for the last one because you have only one root complex connected to one PCIe switch. And the second PCIe switch is connected to the first one. Finally, all these GPUs can communicate each other. Okay, this is the requirement for the GPUs to do the peer-to-peer communication. Okay, now let's have a look how this the peer-to-peer memory access is going to be done. So here is that you have in your program some code like this one. And this one is saying that you are going to talk with device 0, means GPU 0. And then you are going to declare a pointer. And then you are going to allocate 124 floating points, a piece of memory, and point it by this pointer P0. And then you are going to call a kernel. This kernel is going to work on this, let's say, is something like an array with 100, a vector with 124 elements. Anyway, Okay, you launch some kernel function to work on this vector because is located in the GPU memory, and you launch the kernel function in that GPU, and it works. And now you decided you want to talk with another GPU, that's GPU 1. And then you tell this GPU 1 you can do peer-to-peer access with GPU 0. Basically, this is what you are trying to tell the GPU 1. And then afterwards, you can launch a kernel on GPU 1. But that's on GPU 1, remember. And right now, you know where is this P0. P0 is a vector located in GPU 0. We can draw this situation here is that you have a GPU 0, you have GPU 1, you located points to a memory which has 124 elements. And then you have a kernel function, is called my kernel function, which works on this memory. And then afterwards, you talk with GPU, you tell GPU 1 that this GPU 1 could access the P0, which is located in the GPU memory of GPU 0. So then that means GPU 1 can launch another kernel, my kernel, on this GPU 1, but this kernel can access the memory of GPU 0. That means it can access this P0. So this is called peer-to-peer memory access. Now, there are some conditions for this. First is that to have the GPUs connected to the same server to do peer-to-peer memory access, these GPUs has to share a universal virtual address. So it has to UVA. So you have to have this kind of universal unified virtual the addressing between these GPUs. This is the requirement. UVA. And it said here that on non-NVS switch enabled systems, you can only have up to 8 GPUs to do this kind of peer-to-peer memory access. Okay. Now, right now we focus on PCIe. We focus on PCIe. GPUs in the PCIe form factor, if you have not more than 8 GPUs per server, these 8 GPUs can do memory peer-to-peer memory access. But there are some kind of attentions we need to pay. Here is that there is no cache coherency between the GPUs. It's the programmer's responsibility to synchronize the peer-to-peer memory access. Now, this piece of code is from the Nvidia CUDA document. I didn't find out why the AMD GPU support this kind of peer-to-peer memory access or not. I mean, the GPUs in the form factor of PCIe adapters. Now, I didn't find the answer whether it's supported or not. It's just not mentioned. It didn't mention it works or not with AMD GPUs. So this point I don't know, just to be clear. But anyway, things will move on, but here we know that there is this kind of peer-to-peer memory access between the GPUs attached to the same server. Well, there's something interesting. We need to spend some time to think about that. Doesn't that remind you something else? Okay, well, that reminds me the traditional cis-NUMA shared memory system. Okay, so you have CPUs connected by the CPU to CPU cache coherent link. So, for example, you have a four-socket system, and you have four CPUs. The four CPUs, each one is connected to the memory. And you know what? You know, this processor, a core or a thread, can load or store a memory address in another processors located in the another processor's memory. Okay, so it can load or store the memory here, and it can do memory copy. You can copy the data from here to here. Okay, this is the traditional shared memory system. This is just one node. It's a shared memory system. It's just one node. And for this kind of shared memory system, there is the programming model we have talked about in the beginning in section 1, which is called shared memory. Now, this is not it's a bit difficult to read. Now, you can think about that this shared memory equals this shared memory. Okay? You can think that this is the thread is executing here. It can have access to the shared memory, and it has access to its private data. And another thread is the same thing. Another thread is the same thing. Now, this is the OpenMP programming model for this kind of system with multiple sockets, with shared memory, and the CPUs are linked to each other by CPU to CPU cache coherent links. Now, let's just think it. Let's have a look at this kind of systems. You have a node. You have a node. You have a node connected with a CPU, and then you have a memory connected to the CPU. Okay, and then you have multiple GPUs connected to the node. This is just one node. You have multiple GPUs connected to one node. If you just look at these GPU memories, you look at these GPU memories as a whole. Don't you think that it's the same thing as the shared memory for the cis-NUMA system? This is the cis-NUMA system. Okay, is that the same thing as this or not? And you think about this GPU and this GPU. If you think this GPU, could you think that this GPU is somehow in the same kind of position as the CPU here? The quantity is different here, but you can have 4 GPUs per node. Well, then the two pictures are going to be exactly the same. Okay, that's direct memory access, peer-to-peer memory access, right? Okay, and that's again peer-to-peer memory access, right? Okay, suppose you have the node, this is the CPU. Okay, then you can have another CPU if you like, and you have a memory. you have a memory. Why? Then if we focus on this one, don't you think that's too much similar with this kind of Cisnuma system? And if this programming model is okay with this one, with the Cisnuma system, why couldn't it be applied to this GPU system? So that's too much similar. So my conclusion is that the peer-to-peer memory access is something is the programming model. If that's the programming model, that's something very similar to the OpenMP, right? And because in a GPU computing program, you can mix this MPI communication between the GPUs or MPI communication between the CPUs. And at the same time, you can also do this kind of peer-to-peer memory access. You can mix these two. Don't you think that this is too much similar with the MPI plus OpenMP, the hybrid programming, the mixed mode programming? Well, my answer is yes. Let's move on. Okay. In the first section, we discussed this kind of mixed mode programming. Here is that you have two nodes. Between the two nodes, the communication is MPI message. And within the node, if you have only one MPI task, and you can use OpenMP to share the workload between the threads. So all these blue threads, OpenMP threads, belongs to this node, and it belongs to the MPI process. So this is kind of mixed mode programming, but this is for CPU, for computing without any CPUs. Now let's have a look at this picture. This is done by myself. Right now you have this supercomputer node. Okay, I'm going to attach 2 or multiple GPUs per node. Okay, you have the node. You have the GPUs per node. And then the GPUs can access each other's memory. This is called peer-to-peer memory access by going through this PCIe link. Okay? This is very much similar to the OpenMP programming for threads. And here you have multiple threads, lots of threads per GPU, another GPU, maybe another GPU. You have lots of threads. The threads can access each other's memory by the peer-to-peer memory access. If you think the GPU memory belongs to the same supercomputer node, that makes a shared GPU memory, and then peer-to-peer memory access is OpenMP for the GPUs. Okay. Okay, the other side is the same story. Now, there is this kind of GPU-aware MPI and non-GPU-aware MPI. So, if you have a kind of GPU-aware MPI, basically you can realize the message passing between this memory here. Let's call it PSUM. You can send this data going through this GPU-aware MPI and put the data here called PSUM. Okay? This is This is MPI, and this is peer-to-peer. So the programming model for GPU with this kind of systems with GPU adapters in the form factor of PCIe adapters is this is the mixed mode programming, MPI plus peer-to-peer memory access, which is an analogy of this mixed mode programming model. Okay, if here you have a non-GPU aware MPI library, what's going to happen? Then there is some trouble with it. But anyway, what you can do is that as a programmer, what you need to do is that when you have to do the communication, you need to copy the data from GPU memory. No, let me draw it here. You need to copy it from the GPU memory to the CPU memory, and then you call this non-GPU aware MPI library to have this communication happen. Suppose you are going to send a PSUM, let's PPSUM, and you need to put it here, and it works. Okay, so the non-GPU aware MPI is going to send this PPSUM. First, you need to copy this PPSUM to this memory here. PPSUM, you need to copy it here, and then you use this non-GPU aware MPI copy the data to the main memory of the server PPSUM. You copy it here, and then later on, as a programmer, you copy the data to the GPU. You are going to realize this kind of GPU to GPU message passing. You have two steps to do. Okay. Now the picture is getting a little bit complicated. For a GPU computing system with GPUs in the form factor of PCIe adapters, suppose you have multiple GPUs per node. Basically, there could be a mix of two kinds of programming models in play. The first one is the OpenMP MPI programming model that could be applied to the CPUs. And then there is the other set of communication, which includes the GPU and also this MPI library, non-GPU aware or GPU aware. So yeah, GPU computing system, if we look at this kind of programming model, we have two programming models in play. OpenMP, MPI plus OpenMP, the first one in play for CPU, and then you can have this MPI plus peer-to-peer memory access in play for the GPUs. So as a programmer, you have to be ready to mix these two kinds of communication, these two kinds of programming model in the same platform. Right now, for the moment, the MPI here is the same thing, MPI. If you are using if you are using non-GPU aware or GPU aware, basically you are using the same MPI library for your system. And you apply MPI plus OpenMP for CPUs. You apply MPI plus peer-to-peer for GPUs. There are two kinds of programming models in play. That's the the difficulty of this kind of GPU programming, because you have to deal with these two kinds of programming models. Okay, now this is the starting point. You know, later on we are going to find out that is going to get more and more complicated, and this MPI is going to be replaced by Nico, and you are going to have a more complicated programming mix of programming models. But anyway, we are going to discuss all this in the next section. In the next section, we are going to have a look of these GPU computing systems with the Nvidia SXM module, or the GPU computing system with the AMD OM module. That's for the next section, but this is for this section 3. So let's do the summary. We started by discussing that for the GPU computing systems with GPUs in the form factor of PCIe adapters, clearly there is the architectural bottleneck, which is the link between the GPU and the server. And GPU data transfer is the overhead. And that means for the programmer, they have to think about to have as much as threads each time they have to offload their workload. Okay? And then internal the GPU communication, we are using MPI, but be careful here, the MPI library, the communication is for GPU, but the MPI library will be executed, the call to the MPI library will be executed by the CPU. So that's going to be the host program, which is going to deal with this MPI library calls, but their communication, the MPI could be for CPU and it could be at the same time for GPU. That's a kind of mix. And here comes in play two kinds of MPI library, the non-GPU aware MPI library and the GPU aware MPI library. Okay. And then later on, we discussed that if you have multiple GPUs attached to a server, there is a possibility to do this kind of peer-to-peer memory access between these GPUs. And this kind of peer-to-peer memory access is very much similar to the OpenMP, programming model. Okay. Finally, we did a kind of a comparison between the MPI plus OpenMP, this mixed mode programming model for CPU, compared that with this kind of MPI plus peer-to-peer memory access for GPU. Okay. And I pointed out that for a GPU computing program, for the system as simple as this kind of systems with GPUs in the form factor of PCIe adapters, there is already a mix of two kinds of programming models in play. That comes the difficulty of GPU programming. Now, this MPI plus peer-to-peer memory access is very much similar to the MPI plus OpenMP programming model. Okay, so this is the summary for section 3. I'm going to stop here. Any questions? Come back to me. Anything you don't agree with me, come back to me. We can discuss. Now, just to point out, this is the starting point of the GPU computing. We know that with the evolution of the technology, the computing, the GPU computing, the programming for the GPU computing systems is getting complex, more complex. And later on with the evolution, sometimes we get some nice features comes from the architecture of the system that makes this programming model sometimes a little bit more a little bit more simple. So we are going to continue this discussion. I have another 3 sections to go to 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 present. So stay tuned, please. Thank you for your time. I'm going to stop this recording right now.